Okay, good morning everyone. I hope you slept well. I hope. Welcome to our second and unfortunately last day of the Confidence Conference. I would like to introduce Mr. Michał Sajdak, who will talk about embedded devices hacking. And just a short reminder, the teams for the extraction point have to be ready at 11, and we are starting at 12. Okay, let's start.
Okay. So hello everyone. My name is Michał Sajdak, and today I'll show you live two interesting devices when it comes to vulnerabilities. About me, I'm a pen tester and trainer. Also, I post some, I hope, interesting stuff on securac.pl site. And today we'll see this device, so Cisco Security Appliance 500 series, and I will show you our unauthenticated remote root execution here. Current status is patched, and the another device will be TP-Link routers, and also here we'll have unauthenticated remote root access. This is my research from this year, and the current status is probably patched because TP-Link patched it silently. Okay, both of the devices will be presented live. Of course, all the information is for educational use only. Okay, first device, I have it here. And in many, we have OS command execution, Sickle Injection on login screen, and extraction of authentication data in plain text. So let's see it. First, remote code execution, but requiring authentication. So I'm logging into Cisco user here, password. And now, sort of classic trick, I navigate to Administration Diagnostic tab, and here I can see that I can provide an IP address or just address and ping the target host, and I will do it, but before doing this, I will switch my Firefox to use local HTTP proxy. Why am I doing this? Because I have such very simple architecture in my lab. So here is my laptop with Firefox. Here is this local HTTP proxy. I'm using Burp Suite here. And now I can intercept, modify, and replay HTTP request. And now I'll do it. So the Burp is running. Now I'm pressing this ping button. Okay. And I have this request intercepted here on my local HTTP proxy. As you can see, there is this address to be pinged here. I'm not connected to the internet, so this just fails, but I doesn't care here about this. I put it into repeater module, so send repeater. And now this classic trick, I just add here semicolon ls and go. So I send this request to the server, to the device. And now, nothing special here, but when I navigate a little bit further, okay. I see that there is an output of this ls command here. You can wonder what privileges I have here, so let's try id command. And you can see I have root here. This is very simple stuff for now. When I put here ps command, so I want to list all the processes, I will see something sort of By the way, they are using snort on this device as IDS system. But there is something other important, this /tmp/system.db file. What is it? Oh, let's see. Just cat /tmp/system.db. Go. As you can see here, it's SQLite format free database and some binary junk here. But when I navigate a bit lower, you will see that there are table definitions, columns, and so on and so on. In other words, I have all the database structure here. I will delete it for a moment. Okay, to sum up, we have code execution as root here, but it needs authentication. How to get authentication data from this device? Let's see. So I'm logging out of this device. I'm turning off my burp suite. Okay. There is a nice vulnerability here. I mean, Sickle Injection on login screen. It won't be so easy to exploit, but I will show you. First, 2 or 3 words about Sickle Injection, if someone doesn't remember it. So basically, for example, we have a site like this. It shows me specific news, and the underlying SQL query looks like this. So get me everything from the table news, where ID is equal to 10, and the news must be active. And when there is no validation here, injecting something like this, so person20 space or space 1 is equal to 1, person23, results in such query. So get me everything from the table news, where ID is equal to 10 or 1 is equal to 1 hash. This logical statement is always true for every row, so this gets me everything from the database. Hash is a command sign in SQL, so everything after this hash is ignored. Very basics of Sickle Injection. Okay, let's go back to this security appliance stuff. And on the login screen in this device and possibly in every other application, checking if I have entered good login and password looks like this. So the application selects all data from users where login is equal to the provided login and password is equal to provided password. Okay, we control login and password. So if we use something like this, so login and password is equal to quote space or space 1 is equal to 1, quoted in such way, we have the following query. So get me everything from the users where login is empty, it's probably false, or 1 is equal to 1, it's always true, so this part is always true, and password is empty, so this is false, and this is always true. So again, this statement is always true, so we are getting all the users from the database. Okay, so let's try it on our device. If I put here invalid login and password, I have something like this. There's no surprise, but when I put something like this as login and password, actually, what should happen here? It is a question for you. Should it show me an error, or should I be logged into the device? Yes, it should be validated. It is somehow validated by let's try it. I have another error message here. Provided username is not a part of administrator guest SSL VPN. What has happened here? Okay, let's get back to the presentation for a while. Basically, if this query returns something, or at least one row, this means that we have provided good login and password. And if this query returns nothing, we have provided wrong username or password. So if we use this, this query returned in returning all records from the database, and the first user was sort of technical user, so it wasn't in the SSL, VPN, and so on group, so we got this error message. And how can we exploit it further? We'll use blind SQL exploitation. To use blind SQL exploitation here, we need to know some more details. So we need to know database type. What was the database type? SQLite, right. Then we know the table name, and the table name is the table name which stores all the user data. It is called SSL VPN users. It can be extracted using this previous vulnerability. And the columns of this table is username and password. So in other words, this query, so select username, password from SSL VPN users, get me all the users and passwords from this table. And we can't use it directly here because this login screen gives us only two information, invalid username or password, or this user does not belong into SSL VPN and so on group. So we'll have to extract all the logins and passwords, all the letters one by one, and we'll do this using this blind Sickle injection. Before doing this, we need some SQL practice. So this query extracts the first password from the database. If we add here substring function, this returns me the first letter of the first password in the database. And now we'll use a login like this. So basically, after injecting this into our base query, we'll have something like this. So let's see. Get me everything from SSL VPN user where login is empty. It's probably always false. Or we are checking if the first letter of the first password is equal to A. If it's equal to A, this logical statement is true, and we are getting this other error message. So this SSL VPN group and so on and so on. And if it's false, so if the first letter of the first password isn't A, we are getting just invalid username or password. Okay? So let's try it in practice. I'm not logged in here. Now I have to intercept this login request to modify it. Let's start from invalid username and password. Okay. So basically, I need to put this injection here on username, for example. I have it, I hope so, at least copied somewhere here. This is the same as on the presentation, this proposed login. So let's try it. So for example, let's see if the first letter of the first username is greater than A. Go. We have this other error message, so it's greater than A. Let's see if it's greater than, for example, C. We have this error message, so it's not greater than C. Is it greater than B? Yes, it is greater than B, and it isn't greater than C, then it is what? C, right. So let's try it. If it's equal to C. Yes, it's equal to C. Basically, it's the first default Cisco user, so the first letter is really C. If you want the password, I have to just change this username to password. Okay, and another trick. If it's greater, for example, than J. Yes, is it greater than S, for example? No. So basically, narrowing all the results, we have all the letters of passwords and usernames. And by the way, these passwords are stored in the database without any hashing algorithm, so in plain text. This first letter, by the way, is just equal to S, %3ds. Yes. If I need the second letter, I will put here this 2. So this is an argument to the substring function here, and we'll extract the second letter. Okay, that's it for the device, and let's move to the a bit more complicated situation. I mean here TFP devices. It's quite fresh research because it was patched a month ago or something like this. Okay. This is an example of TFP router, but actually most of those routers made by TFP are vulnerable. And here we'll also have finally remote code execution without any authentication. This time this ping functionality doesn't work here, but we have another interesting stuff here. I may plug my USB stick to this device to have a folder or a file shared through FTP or through Samba. So basically to do this, I'm navigating to USB settings. I have here FTP server. Oh, let's delete it, okay? And now I may share a folder from my USB stick to be available on FTP. Let's try it. I have only one folder, it's empty folder on USB, so I'm choosing it and clicking save. Now I can try to log in to the device using FTP. I have this folder 1, it is mapped to this folder test. It's empty, as you can see. When I try to navigate somewhere to the file system, you see that I'm sort of jailed here, so I can't see the file system of the router. But let's try a little trick. Now I'm deleting this directory. I'm putting the communication through the burp suite, so local HTTP proxy, okay. Now I'm turning on intercept button, so if I press this save button, I will see the request here, and I can modify it on the fly. So let's do this. Save. Okay, here is the HTTP request, and as you can see, there is a parameter called shelled folder name, and here is sort of path to this test folder. I can change it, just very plain path traversal stuff here, to something like this. All right, I'm forwarding the request to the server, and let's try to FTP once again. We have this folder 1, and we have all the file system access, also in write mode. The interesting stuff is here that almost most of the configuration of this device is stored in tmp directory. So let's move there. And there is a slight problem. There are no files here. I found that this device runs in sort of loop or something like this, so I have to change its mount point. I'll show you what I mean here. So I'm deleting this directory. Now I'm adding again the folder, pressing intercept here and saving it. And now to have access to this /tmp directory, I have to enter it directly. So something like this, tmp. Okay, let's try if it works. Our magical folder 1. And we have /tmp access here. Okay, now we have access to all the configuration of the router and how to get interactive root shell from this. Okay, I skipped all the configuration files and I found something like wait a second. Okay, here's our router. I found something like Samba here. And now I'll show you this Samba configuration. It's quite common, nothing special here. And I wondered how to execute a code from Samba. So I Googled the documentation and I found something like let me see it. And I found something like this. There is a root pre-exec configuration statement in Samba, and they say that in some situations they allow me to execute code as root, for example, before mounting file systems such as CD-ROMs and so on. We don't have a CD-ROM in our router, but we have a Samba, so we can try to exploit it. How to use this root pre-exec? Just like this, root pre-exec, and the command to be run. At first, I will just ping my laptop. So ping -C1, and my IP address is, I don't know. It is 10.100. So something like this. Okay, let's save it. Now I have to run Wireshark to see if those pings are coming to me. I'll put here ICMP filter. And now, if it works okay, when I access this volume 1, this command will be executed, so I should see this ping on my Wireshark. So let's try it. Here we have our Wireshark. Now I will try to access this share. So I'm putting here the address of the router. Okay, I have this volume 1 here, and after clicking on this root pre-exec should launch, and I should see ICMP stuff here. Oh, as you can see, there is this ping, so it's coming from the router, from 10.1, and it is targeted to my station. Okay, so basically I uploaded a binary compiled from MIPS architecture to the router. This binary allows me to have a shell on a specific port, interactive root shell. So in other words, I got interactive root shell on this machine, but it still needs authentication. For example, to be able to FTP to this device. Then I downloaded HTTPD binary, so web servers binary, and it looks like this. And then I searched for some strange stuff and found something like this, start art. There is something a bit strange. Okay, so I enter it to my web browser and try to access the router. It didn't ask me for any authentication, so it is unauthenticated. And then I monitored what is going on the router. And I found that the router, after receiving this HTTP request, just launches tftp server and tries to download a binary from the IP address which issued this HTTP request. So let's try it in practice. Okay. I need to have this strange URL, start art. This is HTTPD binary extracted from this router using FTP or other method. Okay, now I have to once again start this Wireshark to listen for TFTP traffic this time. And now let's put it here, so this strange URL. As you can see, there are TFTP requests coming from this router, so 10.1, and they are targeted to my machine, so the machine which has issued this HTTP request, and it wants art module /art.ko, and for a while we'll see another interesting file, this nart.out. After doing some research, I found that this router downloads this nart.out file, and it executes this as root. So basically, in this step, we have remote root access. So first, I put or I run this HTTP request, this start art HTML. It is unauthenticated. This forces the router to download this binary from the station which issues this request, and in this binary, I can provide remote root shell to be run on the router. Let's try how it works in practice. So now I'll move to my Linux station running in VirtualBox. I have a TFTP server on this Linux box, and there is a ready binary waiting. So now I am in this TFTP root on my Linux, and I have this binary nart.out. It is just very simple remote shell which listens on port 2222 and is compiled by me to MIPS architecture because this router is running on MIPS. So basically, if we put something like this, so we are fetching this file from the router should get this file from my TFTP server, and it should run as root. If it is okay, then I should have interactive root access on port 2222 on the router. So let's try it. First, there is no listening on this port. Now I'm putting this, I'm fetching this file. And now I'm trying to connect to this port. Is it working? Yes. Of course, everything runs here as root, as always on such devices. So I have remote root access here. And actually, most of TP-Link devices can be easily remotely rooted in such way. By the way, there are also some interesting processes here, like something like this, ask telnet dbg or something like this. So I think that in my spare time I'll try to research it, what they put on this router. Okay, so actually I have only one more slide to show you, but before this, maybe you have some question to this first example, or maybe to this TP-Link example. Okay? Mm-hmm. Okay, yes. This Cisco staff weren't be able to log into the device using this quote space or space and 1 is equal to 1. Because probably there are 2 or 3 queries actually in the login process. So using this simple injection, we can't effectively inject into all these queries.
Sorry, just 1 second. I will give you a microphone, okay?
Hello?
Okay, now it'd be better.
So my question was, because normally we would use just the username to log in, right? But we can ask the database to provide the username for us.
Okay.
So hello, okay. Can we just use the username from the first row of the database and the password associated with the first row of database and use that for login?
Unfortunately, no. I tried it many times, but I didn't achieve to have any working example. So the only thing I achieved here was this another error message. Yes.
Okay, so the only thing that we can do is just look for the username sign by sign, I mean character by character, and then for the password character by character.
Yes. It's quite easy because you can extract every password in sort of 100 HTTP requests or something like this.
Yeah, okay.
So it isn't complicated, and the passwords are stored here in plain text. So no matter what complicated are the password, you can extract it.
Sure, but if it was hashed, then we're out of luck, basically.
Yes. But if all the passwords were hashed, then we could try to extract other configuration like, I don't know, IPsec, pre-shared keys, and so on. Because we have access to all this system.db database, which stores all the configuration of the machine.
Okay, thank you.
Thank you. Okay.
Thanks. I was curious whether the IP address of the device which serves actually the TFTP files has to be in the same subnet as the router, or maybe?
No.
Okay.
It is remotely exploitable.
Cool.
So in short, I put my, of course, device to the internet and then tried to use it on one interface, and it worked.
Exactly. Thanks.
Thank you. Okay, do you have any other questions? Okay, so if you like the presentation, I invite you to the securac.pl site and ask you for liking it on Facebook or just it. There is another, I think, nice initiative, unfortunately only here in Poland, in Krakow, called Secure Hacking Party. And basically, we're gathering and trying to find as many vulnerabilities like this in devices. And one thing I'll be showing on this Secure Hacking Party are vulnerabilities in HP network printers. They are already confirmed by HP, but I'm waiting, I'm giving them some time to have it patched. And I'll be publishing it soon, in a month or something like this, on Securac and on the Securac Hacking Party. I'll be here for a moment, so if you want to ask me something, feel free to do this. Thank you very much for attending.
Okay, thank you very much for your speech, of course. And just short reminder, at 11, the extraction point teams have to be ready near the game zone, and we are starting at 12.